cross section. Let's say you have a beam. This using the structural design construction end beam. We call it end beam. And you can see if you cut a cross section, it's going to be L like that. Okay. Now some dimensions are given. So the width is 1 inch, and the part of length of the entire L shape is 6 inches. So what we want to do is to find the centroid of this composite shape. So this is an example of composite shape that is composed of simpler shapes. So we are here and now the question is find the centroid of the entire overall shape. So again, I'll go to the formula. The formula that I have says x bar is equal to summation of x bar I ai over summation of ai. So that gives the x location of the composite shape. So this is the overall shape location of centroid is equal to the vector summation of the centroid of each individual shape times the area divided by sum of the total area. So if I get all these numbers, I can plug it in and I can get x bar. So what's the formula for y bar? The same formula, you just plug y. So you get y bar is equal to sum y bar I ai divided by sum ai. And don't forget that you don't need to memorize this formula. This will be given in the appendix. If you have a test or anything, you just go to the appendix and get the formula. Now, in order to compute this x bar and y bar for the composite shape, first step is to decompose this shape into simpler shape that I have the formula for A and x bar, right? I don't have the formula for x bar of L shape, but I know that I can decompose this into two rectangles, one here, right, and one here. Again, it's your choice. You can take this entire thing A1 and this part A2. You can take this part A1, A2, and this tiny square here A3. It's completely your choice. You don't have to do this, all right? So I take this A1 and I take this sub part A2. Now, all I need is to find each individual thing in the formula and plug it in. So what I do, I make a table to keep me organized. You don't have to make a table, but this keeps me organized. Shape AI x bar I AI times x bar I. So here shape 1, shape 2. Now I need to fill this table in order to be able to compute the centroid of the composite shape. So let's start with A1. What's the area of this part only?
7 times 1.
7 times 1, which is 7. A2.
The same. 6 times
6 times 1. Now, don't forget that the coordinate system, you can put it here, x, y. You can put it here, you can put it here. It's your choice again. Exactly like the way you decompose it into sub-shape. Choosing the right coordinate system is your choice. What I do, I put it, for the moment, I put it here. So let's measure everything with respect with respect to the coordinate system xy located at this corner, bottom left. So now, when we know the coordinate system, what is x bar 1 for shape 1? So what's the x coordinate of the centroid of shape 1 only? Shape 1 only. With respect to this. So I know, yeah, 3.5. I know the coordinate of this guy is at the center because this is rectangle. That's the advantage of decomposing the composite shape into subshape, right? So it's right here. And what's this center? If the total thing is 7 plus 1, so it's 6 plus 1, which is 7. So the x bar will be 7 divided by 2 with respect to here, which is 3.5. What about area 2? What's the x bar with respect to it? Oh, 0.5. Would be 0.5. You see, right here. Now, this thing depends on these two columns. So once you get these two columns, then you can put a formula here. Whatever here is equal to this time this. So let's compute the third column. Seven times 3.5 24.5. 6 times 3. Now, sum of area would be A1 plus A2, which is 7 plus 6, 13. And sum of AI, x bar I, would be 27.5. Alright, so finally, I'm ready to put it in the formula. So here is the formula. X bar of the total shape is equal to, if you expand this, you get x bar 1A1 plus x bar 2A2 divided by A1 plus A2. So that's in fact this total sum here, right? So once you get sum of this column, no matter how many subshapes you have, if you sum all the rows, then you get this number, just put it here, 27.5 divided by this sum, which is 13. That's going to be 27.5 divided by 13. 2.11. Let's say 12 inch. X bar. So here is another important thing. If this shape was filled everywhere, let's say this was a solid box like that, what would be the centroid if this was filled everywhere? The centroid would be here. So x bar, which is from here to here, would be 3.5. But look what I got, 2.12. So the center is, the x bar center is shifted a little bit to the left. Why? Because this is not all solid. You see, you have more area contribution here. So this acts like a gravitational force that is pulling the centroid to the left, because you have more contribution here. So that's the reason you get. So you always compare your, because you may do something wrong here, and then if the final answer is, let's say it was 4, then you would say something is wrong. Why? Because even if it was filled all the way, I would half of this, which is 3 point, but now I got 4, which is here. So it's wrong. Either the coordinate system is computation is wrong or something like that. You have to go back and reiterate, right? But you see that, okay, this is closer to this area, so it makes sense because you have more area contribution here. You see that? Now, how can I compute y bar? Same thing, you just replace this column with y bar. And as a matter of fact, this column will be updated by ai times y bar I. And this sum is different, so let's do that. But look, according to the symmetry, y bar should be equal to x bar. The x centroid should be y centroid because it's like symmetrical, right? So let's do that. Let's see if we get the same result or not. So again, shape. I need a better marker. AI. I get y bar I. And finally get AI y bar I. 1, 2. Again, A1, 7 is exactly the same column. 7, 6. Sum area is 13. It's the same column now. We go to y bar. Y bar 1. This shape 1 with respect to this coordinate system is 0.5. Y bar 2. We go to shape 2. This is shape 2. Up to here, you see? So y bar is 6 divided by 2, which is 3 from here. And then I have to add this segment to it, right? So 1 plus 3, which is 4. Now I'm ready to create the last one, so that's going to be 3.5, 24, 27.5. So y bar is equal to this one, this is sum ay, y bar I. Sum ai, y bar I divided by sum ai, which is equal to 27.5 divided by 13. It's equal to, which is the same, 2.12 inch. Well, this is a result that you knew it from the beginning because this is symmetric. So if you take the x bar, just flip it the other way, you get y bar. So this is the centroid of the solid field, but here I only fill this area. So that's my actual centroid right here. So this is x bar, which is 2.12, and y bar from here 2.12. This is smaller than the actual half, which is 3.5, because we have more area contribution here. Example number 2.